Thank you, thank you, thank you. And welcome to demo night. All right, so what we're going to do is we've got 9 demos. And so each demo is going to have basically 5 minutes for the demo, 5 minutes for questions, 10 minutes total. So if you go over your 5 minutes, it counts as part of the 10. But I think that's going to be good for most of you. We wanted to keep it quick and interesting and exciting. So we're going to kick it off right away with Chris Weber. And he is, well, let's see. I was supposed to give an intro, and there were only 2 things I was supposed to say, which is that he's active in ActivityPub and data shards. So I believe he's here to tell us about data shards. Go ahead. Take it away.
All right. So this is a very brief talk about data shards. What is data shards? Data shards is secure distributed storage primitives for the web. I'm going to go through these slides very fast. So only intended recipients can see the message, which even actually makes it safer for node operators to help the network. If you can consider why, if you were voluntarily helping ship things around the network, you may be more liable if things were wrapped in saran wrap than if they were wrapped in paper. It's also secure against size of file attacks. The stores can be in many different places. They could be on a USB key, they could be on a web store, they could be over a gossip network, and blah, blah, blah. And nodes host content but don't actually know what it is. And the ideas are based off of Tahoe LAFS. And we hope these things will be foundational, the way that HTTPS is foundational for live content. And we provide both immutable data and also a mutable data option. And the cool thing is, once you upload this to one of these stores, it has the same name no matter whether you store it on the USB key or in the web store or whatever. But whatever, I'm going to show you a demonstration both in Racket and Python. So I have written a Racket implementation, and Serge has written a Python implementation. But I need to send Serge these secret Death Star plans. But just so you know that I'm not hiding anything up my sleeve, somebody in the audience tell me something to write on this message.
One word.
One word.
R2D2.
R2D2. Okay, I'm going to export it. Whatever. Don't give me a hard time about that. Okay, so I've already pre-configured this thing, so what this is going to do is it's going to upload Death Star to Serge, and then I'm going to generate a little QR code here. All right, I've generated a QR code. Serge is going to come and scan it, and there it is. Now, I am running a store on my computer that I'm hosting over a web store, and that web store is cannot tell what information we transmitted between us. So that's really the cool part here. So anyway, that's it for the demo, actually. I could show you more things if you want to, but we figured you might have questions.
So it says no usable data, so it's...
Wait. We have a mic.
So when I see when I try to translate the QR code, I get no usable data. Is it a URL? Is it some proprietary?
It says
format?
IDSC : blah blah blah, and I'll show you actually exactly what it looks like, because I'll actually do an upload real quick. IDSC. So I'm going to upload just this little 8sync logo thing here, and just for extra fun, I'm going to type verbose. So what the IDSC URI is actually that bottom part, IDSC : blah, 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 blah. And that contains both the hash of the initial chunk that we're going to fetch, and then the key to decrypt it. And in fact, you can even see that chunk there is actually the last one that it says that it posted in the debug mode. And the other ones are the other data chunks that it ends up retrieving. So everything's broken into 32 kilobyte chunks. And the reason we do that is you can imagine if you had, it was Christmas time and you're like, boy, I really hope I get that Brontosaurus, like action figure for Christmas. I wonder what's under the Christmas tree. And you look under the Christmas tree and somebody just wrapped that Brontosaurus thing in wrapping paper, and it's shaped like a Brontosaurus, and you're like, okay, I know what I got for Christmas, right? So we want to obscure things so that you can't tell by the size of the file what type of thing it's going to be. Cool. Other questions? Is everybody stunned and amazed and there are no other questions? Okay, go ahead.
Why do you hate CBOR so much?
Why do I hate CBOR so much?
Why is it encoded in the way that it is? So there are primitives that you're not using, like multi-base, multi-hash.
Well, okay, so the multi-base, multi-hash, this is partly things that we're talking about offline and probably isn't as important to the audience. The way that we're encoding things, we're using canonical S expressions. And because canonical S expressions took me an hour to implement because they're the simplest thing in the world, right? So I implemented that. It's a binary composable data serialization format. So it was really easy to implement, and part of it was speed. And I didn't have an implementation of CBOR, but the other reason is I'm actually not very convinced. I'm not completely convinced of CBOR when we're examining things, and part of that has to do with the fact that it doesn't have an extension type. And I think that that's actually going to be a serious, I think that that's part of the reason why JSON LD has had so much trouble. And I'd like to explain that to you later, and that's why I'm advocating for preserves, which we might switch this over to, which has an extension type, which we don't have in JSON.
Somebody send me the link for preserves.
Yeah, I can send you the link. It has both a textual and a binary format as well, which is really appealing. Yeah. So any other questions that are not about the serialization format, or should I hand this over at this point?
You got time.
Okay, I have time. Any other questions?
Okay, so the basics, what
What kind of symmetric crypto are you?
So we probably could use something better than what we have now. This was a quick, as soon as we could put it together, demo. Right now we're using AES-CTR. We're procedurally generating an IV for each chunk. And that's it for the symmetric side of things. For the asymmetric, for the mutable ones, those do use an asymmetric key, and that one we're going to completely replace what we currently have, because it's currently RSA, and we're planning on moving to elliptic curves and actually just embedding it straight in the key, in the capability. Yeah. Okay.
Talk to the Shamir stuff about shards, is with that kind of sharding.
Yeah, so the word shard may actually create some confusion here, but actually so Shamir sharding is actually interesting, and it actually comes in as a way. So I've made an argument before. You could very easily implement a did method on top of mutable data shards. Just store a did document in the mutable data shard and update it, right? And one of the things that I ran into was, okay, how am I going to do key recovery? And then I realized, we could just have the right capability be stored across Shamir, I can't say the words, Shamir shared secrets. It's a tongue twister to me. So for anybody who doesn't know, that allows you to split some information into, like, let's say 5 people, but then you only need 3 of them to get it back and stuff like that. So I think that's a different use of the phrase shard that is a little bit different than how we're using it. But Serge proposed data shards, and we thought it was a cool name. So, Okay, I think I should probably officially hand this over now. Thank you.
All right, thanks, Chris. Next up, we have Sam Smith telling us about SeedQuest. So please welcome Sam Smith.
Can you hear me? Sort of. All right. So a year ago in Toronto at this meeting, I showed a very early proof of concept of this app. So a year later, it's a fully functional app. It's still in active development. Would love to have you go to the GitHub repo and download it and play with it and submit all of your comments about how to fix it, because we're still evolving the UX by quite a lot, and you'll probably see a bunch of UX things that you don't like, so please comment and say you'd like them better. One of the problems that we're having is that we have 2 audiences. We have the technical audience, and they're much more persnickety about things, and then we have the non-technical audience, and they're completely confused. And so somewhere in between, we're trying to find a happy medium. So the purpose of SeedQuest is a 3D game mnemonic for learning 128 bits of entropy. So you can have your cryptographic seed that you can use to generate your public-private key pair and recover it merely by playing a game. So it's complementary to many key management methods. It has some advantages in that it's self-contained. Anywhere you happen to be, you can download the web version of it, play the game, and recover your key. You don't have to carry hardware around or run home to your safe and pull out your printed backups or something like that if you can't remember your key or have to have all of your shards online or interacting. But it certainly isn't the only way to do it, and it's probably not for everyone. But one of the things is that early on people said, 128 bits, you can't do that. The best mnemonics are only getting 32 or 48 bits without lots of effort. Of course, the 12-word seed phrase is 128 bits, but who wants to memorize 12 words from a dictionary in order? And that's no fun, and it takes a lot of time, and most people will never try it. So we're going to play the game. This is the demo. And there are different ways you can generate a seed phrase right here from a BIP39 key or a hex key, or you can just paste in a BIP39 seed phrase or your hex key. In this case, I'm just going to paste it in, generate it someplace else. It tells me that, yeah, that's a valid key. And now I'm going to play the game. So what it does is it encodes the key to a series of actions in a series of worlds. So the first world is the magic tower. The next world is a cafe. The next world is a pirate ship, a dino park, a saloon, and a gym. So part of the mnemonic is remembering those 6 worlds in order. So people feel like you can remember those 6 things in order yet? No? Okay. Yeah. Magic Tower, Cafe, Pirate Ship, Dino Park, Saloon, and Gym. So, Magic Tower, Cafe, Pirate Ship, Dino Park, Saloon, and Gym. You do one more shot. You have to remember a total of 18 actions, 3 actions in each world. So the first world, you have to feed the baby dragon some birthday cake. The next world, you have to cast the Aquario spell from the spell book and choose the Wand of Goop. So we're in the Wizard's Tower, and this icon over here is telling us that the first place we want to go feed the baby dragon is not in view. We have to go over here and find it. So we're going to go exploring, see if we can find the baby dragon. And he's down here someplace. There's the baby dragon. So we're going to feed the baby dragon. And what are we feeding him? Birthday cake, right? So it tells us right down here what we're supposed to feed him. But in case you can't remember. Now the next thing was the spell book. So we're going to go over here to the spell book. And what spell are we casting? Aquario. So, yes, okay, Aquario. All right, and then now we have to do the wand choice. So we're going to go back up here, and there's our choose wand. Oh, we got him confused a little bit there, going too fast. We're going to choose a wand. What wand are we choosing? The Wand of Goop. Now, if you don't feel comfortable with those 3 actions, you can play the scene over again until you feel that you got those 3. Since you guys are all really smart, you don't have to do it once, right? So the next one is the cafe. These are the 3 actions. Okay. Pastry case, dessert, and student. So I'm going to do less talking and more playing here. You can zoom out here. Two more. We're almost done. There's actually sound. For some reason it's not playing on this system. So there's like music and stuff playing. Yep. And the last scene.
3 minutes, we got to unplug it about.
Okay. Almost done. I'm going to do the sports jersey. All right, so that's our learn key. And then If we want to recover it, so we want to go into, this is a fast recovery mode. We can do it the slow mode. This is a fast way to recover it. So you would go back out to the, sorry, I'd have to go out to the start. So since I've only got a couple of minutes, I just wanted to show you that to recover it, you have to, it doesn't prompt you now. You have to remember Magic Tower, Cafe, Pirate Ship, Dino Park, Saloon, Gym. So I got those 6 right. And now,
We don't have time to go through all of them.
no, I'll just do the first one. So I'm going to do fast recovery here. Just shows me a map. So what was the first one? Feed the baby dragon. What are we feeding him? Birthday cake. Great. Now we have the spell book, Aquario. And then up here we have Goopy Wand, Wand of Goop. There we go. And then, so recovery, once you learn it, you can recover it much faster than the first time through learning it.
Okay, we have time for about a minute for questions.
Oh, there's the music.
One thing that amazes me about this particular demo and the one you did before is that the social key recovery of all the brains in this room, in the previous example of this, we actually were able to completely recover it after one playthrough, completely from the randomness of the people in the room, remembering little pieces of it. And I still think that part is amazing, and I don't know how to use it, I don't know how long it lasts, but it's interesting.
Yes.
Have you tried when did you develop this?
We started working on it a little over a year ago.
Okay, you tried saving something a year ago and tried it again
Just a second.
recently, see if you
We want to catch the questions.
No, the one a year ago was not fully functional. It was only like a couple of scenes. So we've only had the fully functional one since like May, where you could do 128 bits. So, and so those of you who went to IAW in May, we demoed that one. I don't know if anybody saw that one. The difference between that one and this one, it's significant. But this version now is fully functional, and we've frozen the series of actions. So if you do learn something, you know, the UX might change or the layout or stuff, but the actions won't change. So it'll encode to the same.
next time I see you, if I
Yeah.
Thank you. Thank you. We're out of time. Sorry. I'm sure you'll be happy to answer questions later, right? All right. Thank you, Sam. Okay, and next we have Reeks. How do you pronounce your last name?
Joosten.
Joosten. Okay. Thank you. And I don't understand your title from what the words I saw. So
Yeah.
why don't you go ahead and tell them what this is
Okay.
about?
First of all, this is Dutch. We do this in the Netherlands. We have a self-sovereign identity lab, and one of the things that we do is we try to get businesses to understand what you can actually do with this stuff. So this is not so much about the technology, but this is about what businesses can do with it and what users will benefit. And this is a demonstration that we gave to the province of Limburg, and that's a government body, and that has forms, and people fill in forms all the time, and that's annoying, and it takes time, and it has to be validated, and it goes by hand, and they log in to all sorts of authentic registrations to see if you have written down the right stuff. And this is to show them that a number of these things can be made easy. And to do that, I first have the app. This is the app that the Rabo also uses, David Lamers. Basically, it says, who am I? And it has some credentials. For example, a credential of the basisregistratie personen. That's a Dutch thing of the person registration. And if you look into it, then you get an idea. You can see that there on the screen. The names, date of birth, and these kinds of things. Also, the RCE, that is a government body that deals with monuments. And I have here an attestation or a credential that says that I have actually acquired a subsidy for a monument. The monument, the official monument number is here, that's the 8268. And I have asked for 9,000, and that can be subsidized, and 45,000 euros has been actually assigned. And there's lots more. You can stuff anything in these kinds of credentials. So this is a credential about a monument, right? Not about a person. So when I have this app with these credentials, I go to the portal of the province of Limburg, and I request for a additional subsidy that is only if the monument is in the province of Limburg. And this is, except for the 2 QR codes up front, this is a form that is actually being used. And rather than providing all this information, and we'll see there will be a second page, I can scan the QR codes, and I can share the information. And as you can see here and here, 2 of these tags have been set, and an amount has been filled in, and it knows about the monument and stuff like that. So that's things that I don't have to fill in anymore. And the second thing is I have to scan this other thing, and it tells me, oh, it's asking for this person information. I share the information, and then it also knows who is asking it, etc. And you can also see there is this check mark has been filled in, which basically says a natural person is asking it rather than an organization. The remainder of the form has to be filled in either because there is no way to get an attestation or a credential, or the organizations that could provide such credentials do not use SSI, right? So if I can get them to use SSI, then it makes the stuff more simple. But if they don't, then, well, I do it with what I can get. So there is a path, there's a development path in starting small and then getting more and more people on board and making things simpler again. So if I fill in the remainder check marks, then I get the second page, and of course I have to do some other manual checking. This, for example, this first question is about een Stichting Monumentenwacht Limburg. Basically, that's an organization that could have provided me with a lot of information. So I will make this and I'll have to fill in some dates when I have start the work, when the work will end, and stuff like that. And here I have to answer a question, and then when everything is complete, then I can request. I can send in the request, and 5 minutes. Okay. So. Basically, this doing so has allowed the province to gather all the information, part of which comes from credentials and hence is validated, which means that the validation process of the province becomes cheaper and faster, and part of which still has to be done by hand. There is a continuation of this demonstration. There is also a predecessor, like how do you get these credentials on your phone in the first place, but then I would run out of time and I'd rather have you put some questions to me. So any questions?
You first.
So I think there was a credential request that popped up in a QR code, and then you scanned it with your phone, and the phone auto kind of sent it, I guess, to some back-end service?
Yes.
So could you explain that process in a little more depth?
Yes. Basically, when you design forms like this, you start out with a form that is purely manual. It's the way it's done today, right? And you know the information to ask because that's what you need in your process. We assume that credential issuers have some way of advertising their credentials. That's outside of the scope. And they say, these are the kinds of credentials I'm going to issue. This is what it means. This is how I have verified the stuff. This is the liability I'm going to take. This is the endpoint where I'm going to get it. All that kind of stuff. If that is advertised in a shop or a catalog or something like that, then the form developer can tell, okay, so I can put a QR code that asks for this credential inside the form, and when this is scanned by the app, well, as usual, the app will just go and see in its wallet, do I have this credential, and if so, it'll send it over, and there is a proxy next to the standard Apache web server that takes it, that checks the signatures and everything else, and then passes the payload up to the web server through an API that will then just fill it in the form, right? And basically that's it. So we have a parallel channel, and we allow for both manual filling in and doing manual processes, but we can we augment it with this electronic, with this SSI-enabled thing. Does that answer your question? Okay.
Any other questions?
No, I don't think so.
All right. Thank you, Reeks.
Yep.
All right, so who went someplace interesting for dinner? Come on. Everyone ate, right? Okay. You went someplace interesting. Where'd you go? Vegetarian Asian. I have a suspicion about who might have. You didn't arrange that. Steampunk Underground Alternative Bar. All right. Wow. Okay, so which wins, do you think? All right, can anyone top that? Nope, nope. Okay, maybe next time. All right. Chris is here to tell us about, I forgot to look at your title.
It's
Hermit,
Hermit.
I'm guessing.
It's a-
All right. Welcome, Chris.
Thank you. Hermit is a command line sharded wallet for air-gapped deployments. It's a sharded Bitcoin wallet. Shoot. Oop. Sorry, I'm terrible at demos. So, I'm from Unchained Capital. We're in Austin, Texas. We lend fiat money for crypto as collateral. We're in the collaborative custody business. We get we sign on multi-sig transactions. But our security of our key matters a lot to us. So we want a signing situation that's air-gapped, that's cold storage, that's cheap. We have company constraints, like we have employee turnover. We need to be able to rescind keys, all of that stuff. So we've come up with a solution that meets some of these criteria. And maybe it'll meet some of yours, probably not. But it has some interesting things to it anyway. There's a lot of hardware wallets out there. If you've ever used one, you know that they have some problems, especially if you're signing something big. It's hard to tell what you're signing on a tiny little screen, or you have to trust that whatever's on your machine, on your laptop, is showing you the right thing. There's another solution out there that we've sort of patterned our thing off of, which is Square's Sub-Zero. And they've published sort of a white paper about what they do. They don't quite have all the details of exactly what it is, because I don't think they published their HSM code. So this wallet also implements SLIP 39, which is Satoshi Labs Shamir secret sharing scheme. It doesn't quite fit our need, but we wanted to be standards compliant, and it kind of fits our need for something in particular. So let me go straight to the demo. Hermit is open sourced. It's a Python module. As you see, I've just installed it. You run it, and you're in a text-based environment for doing stuff. It sort of has some modes. I can list the shards that I've got. I've built some already. I can, from here, export a shard as a QR code. Oh, I gotta tell it which one. And so I can take that and take it somewhere else if I need to. The same thing, I can import a shard as a QR code. It'll bring up a camera and ask for one. I don't have one convenient. So in the main wallet part, it lets you, hang on, quit. Export an XPub, and I gotta give it a path. 45. Oh, this is gonna suck because I typed it wrong. Let me try again. Okay, so somewhere in there I unlocked the wallet. In the shards get stored in an encrypted way. And this has pulled up the XPub for a particular path. And I can take this somewhere else to somewhere that's not in a vault in the bottom of a building hidden away, and use it to sign a transaction, or not sign, request a signature for a transaction. So I take this, I go do some other software somewhere, and I come back and I have a transaction request on a QR code here. Hopefully it'll work. It's a big QR code. Oh. It knows that it was a testnet request, and it thought it was on mainnet. So it presents the details of the transaction that you're signing, asks you if that's really what you want. Hopefully you've printed something out that says that that's really what you want. You hit yes. My unlocking the wallet timed out, so I have to do it again. And there's a signed transaction to take back to somewhere to broadcast it on the blockchain. So what is Hermit really? It's open sourced. You can find it at unchainedcapital/Hermit. It's actually using Trezor's code for the Shamir implementation. It's designed for air-gapped deployments. It's certainly not perfect. To do this in a secure way, it requires a lot of OPSEC wrapping, and you'll have to supply your own. It doesn't do multi-sig in itself, but we have another thing coming out soon, an open source multi-sig wallet that runs in a browser that will be compliant with the QR codes that come with this. I don't have a copy of it right now. It's not HSM compatible, and it's certainly not an online wallet. So, any questions?
Surely there's a question for Chris.
I'd be happy if there's not. I hate being up here.
So, you said that the Shamir wasn't quite ideal. What would be better?
I'm not sure exactly. It's a question that I don't know the answer to at the moment. Something that's really revocable.
Okay. Is verifiable secret sharing an important?
Not really.
You don't need to verify that
I don't
it's been
think so.
properly backed up.
No. I don't believe so. Maybe. That might reduce some of the sort of OPSEC ceremony of provisioning the thing.
Any other questions? All right, thank you. Let's give Chris a hand.
I have a process question. Can we tweak pictures of the screens?
In what-
What's the republishing rules around if there's a slide on the screen?
Okay, so I guess at this point, we've said that we're making this video available. So if there is a demo, somebody who doesn't want us to show something, we needed to know a while ago, because we're recording it now. So
Computer?
If there's a demo person who says, hey, I really would prefer my demo not, let us know soon.
Okay, so,
I will try HDMI. Yeah?
all right, Amy, what was the name of this alternative place you went to? Oh my gosh, okay.
Cavana Clobu Cross. It's 10-minute walk from here. It's great.
So what was it you liked there? Did you have something really cool to eat? Vegan pizza.
It's an omni menu, so there's for
Omni menu. Okay.
But it's like they have a huge multi-layer courtyard and it's a steam
Wow, cabaret as well. Okay, that sounds pretty cool. All right. All right, so who went sightseeing during the break?
I did.
I was going to say, I know at least two people did because I came across them. Up. Wait, you're ready? So, all right. Okay. I think, yes, please welcome Stephen Gorp.
Sorry for the interruption. I'm Stephen. I work for the Dutch government, and I would like to show you I'm really proud of this project because we are preparing an implementation of a verifiable credential solution in 4 municipalities. And the code is there. I will demonstrate how it's working. It's a simple paper wallet, and we try to bring this into production in Rotterdam, Haarlem, Schiedam, and Harderwijk. And the main goal is to have this up and running early 2020. And this is the original, you saw the personal registration, Rieks Joosten was showing. This is my personal official registration of me, Stephen, living in the Netherlands with my living address history as well. I paid 20 euros for this and get a paper, and this piece of paper is a proof I need for renting a house in The Hague. And basically we built this one in a paper wallet with the verifiable claim with the same information, and I will demonstrate that one. I hope my computer will survive. So apologies again here, because this is a demonstrating clerk front end, so I'm a civil servant in the municipality, and we skipped on purpose the identification part here. Because that's a whole different area. You're not allowed to have a digital identification without using the centralized DigiD solution within the Netherlands, and we didn't want to end up in that difficult discussion, so we scoped it, we have it out of scope, and we decided to have the identification via the normal way. So I have my license here, so I go to the civil servant in the office on the city hall. This is my license, and on the back of my license there's a social security number. And after being identified, the social security number is, I will pick up an example. Sorry? This is a fake number, you can imagine. So here is a selection of the registration. But we are pretty good in the Netherlands registering stuff. So we have a whole bunch of registrations. So I can easily think of a little drop down here, because each and every one has my social security number as a key. Which makes it also a number which I'm not happy to have this one on my license, because it's a meaningful number nowadays, and that wasn't supposed to be. I get the message here, and can still on the desk confirm this is indeed my information. So not the registration is leading, but the confirmation for me that that current registration is still the actual data, that confirmation can be done. That's also a crucial part. On the original one, I got on my paper, there's no way I can anyhow influence the data that's on that paper. I need to go back if it's not correct. And then we're basically ready. Sorry? Oh, yeah. And here you see a sort of a copy, because it's a paper wallet. And in the QR code, there's the signature of the civil servant, the certificate of the authorized supervision he is working for, and the certificate is linked into the, in the attestation DID, and the signature is linked to the, how do you say it? Oh, sorry. I can download this one. I will put it on the screen. I can download this one. And so I have my own proof. I can print it on my lousy printer, because there's no security on the paper needed, because that's cryptographically signed into the QR code. And I will switch to the information here. Sorry. That one. Yeah. The code is on GitHub. This is the screen. We can easily load those data into various wallets. So the SSE wallet Rick Joosten was showing, or maybe the SSE wallet the Rabobank is building, die can easily be filled with the data from via this QR code, because it's using the same standard. And that's what I was having problems explaining is written down here. So this is how the cryptographically thing is done. And the code is on GitHub, and I told in my team, or on other occasions, the biggest problem is to have this one in production, is have people become accountable and willing to become accountable for the 24/7 services we need to get this one up and running. But basically we have built a verifiable claim DID solution for a paper wallet we can introduce in production early next year. I'm ready.
All right, questions for Stephen?
I didn't quite catch, what DID method are you using for it? What ledger or
our own
registry? Yeah, okay.
Well, basically, we have. I skipped that one. We started in 2017 in a blockchain hackathon with a strong conviction we can reinvent the government. We gave the branding, Disciple, you called it, distributed collaborative information platform. And we tried, and we are now running a DID in a Disciple branch name, and we tried to combine the X509 certificate in the PKI stelsel to the DID methods. But that's all on technical level, I'm aware of.
I have a question. So why are you using the traditional PKI system in addition to
Sorry, okay.
DIDs? Okay, I repeat my question. Yeah. So I just see you have the traditional PKI system in place. Do you use this on top of DIDs or in addition to DIDs? Well, why did you choose to implement this in addition to DIDs?
We brought a short paper to this Rebooting Web of Trust with a proposal to have a DID method or sub-method combined with the X509 certificate. And the reason is we need to have this one up and running in production, but then it needs to be legal. Because if I show this piece of paper I earlier showed and I paid 20 euros for it, that's legally accepted. If I come up with my own printed version, QR code on it, there's no legally acceptance of that one. So I need to somehow, in a hybrid situation, connect to the current legal system running on the root certificate of the Dutch authority and move away from that via verifiable claims and ownership of data. And maybe decentralized certificate of solutions that are developing might end up being a better platform to do that.
So this is you connected a qualified signature or qualified certificate with your DAD basically.
Well,
right?
it's as I said, I need this stuff to be legal. Yeah. And the only way happening is to trust the current certificate system.
And I guess we're done. No more questions. All right. You've had, all right. Thank you. Thank you. All right. Manu, did you want to tell your joke? Yeah, you know the great one you told at dinner? It's the verifiable credential, decentralized identifier, and zero-knowledge proof walked into a bar. You don't remember that one? I don't know why you don't remember that one. So I guess I'm going to have to tell it, but not right now. Please welcome David Lammers, who's going to tell us and show us something really cool with zero-knowledge proofs.
Thanks, Daniel. Yeah, my name is David Lammers. I'm working for the Rabobank, and in the blockchain team, I'm responsible for identity, self-sovereign identity, for the development of the mobile app and the backend, and also for the use cases within Rabobank and for our clients. And I will tell you something about a new use case we are doing right now. So it's income test for social housing units within the Netherlands. Half a year ago in Barcelona, I told you something about mortgage, how we try to speed up mortgage application process within Rabobank using the identity app. We're doing projects on KYC process. This year we're also doing a pilot with HR to onboard new employees in a quicker way because they can provide certificates they retrieved within the Netherlands at the Rabobank, so we can onboard them quicker. And I will tell you something now about social housing and the income tests. So the problem in the Netherlands, we have more than 2 million social housing units. And an income test is required by law, but it's a very complex process, and then 0% error rate is allowed. So there's really like a 4 eyes principle when people are typing the data into the system from a PDF or from a printed paper. And the minister has promised to come up with a solution this year, and it doesn't have to be like a production-ready solution, but at least a pilot. And we will play a part with the identity app. So in this use case, we want to appoint a social housing unit to each citizen in an easy, secure, and trusted way. Little bit background, a short background of the identity wallet. Well, we have a mobile app, and we are developing like the backend. So we have an issue or verify backend we can offer to companies that would want to issue or verify credentials, and they don't need to have any knowledge about verifiable credentials, blockchains, DIDs. So they can easily integrate their legacy systems, their current systems, with the self-sovereign identity solution we offer. So it is for them, for the proof of concept we did, it takes a few days for them to integrate. And we also make use of the universal ledger agent. We wanted to prevent that everybody's ending up with like tens of identity apps, each using a different standard or different blockchain. So with the universal ledger agent, we created an abstraction layer with different modules. For different technologies or blockchains. So on the holder side and the verifier side, you can use multiple plugins to support multiple types of credentials. So the issuer is choosing one type of standard, so it can be sovereign, or we have also modules for verifiable credentials on Ethereum. And the holder can save those types of credentials in one identity wallet, and the verifier is also able to verify different types of credentials using the same backend. Well, just to give you a feeling what these modules are, Well, we have multiple modules. They will all be open source. I hope later this month. Take some time to do that within a corporate like Rabobank. But we have modules for verifiable presentations and verifiable credentials, and also some standalone modules for like crypt utils that's handling all the HR private keys, derivations, etc. And in this use case, we integrated zero-knowledge proofs for the first time. So we used a paper by Fabrice Baudot, efficient proofs that committed number lies in an interval. It's been used in several zero-knowledge range proofs implementations, and we had the JavaScript implementation available. So we used that in our solution. And what basically changed was the issuer and the verifier process. This is our current, our normal issue process. So the IDs are exchanged, a verifiable credential is sent to the holder. And on the verification part, the holder shares his verifiable credential and proof of ownership, etc. For the zero-knowledge proof process, actually 2 verifiable credentials are sent to the holder. So there's one public verifiable credential. It's not really public, but you can share it with verifiers, and it does not contain like the real value of the data. So it doesn't contain the income, but the private credential does. The reason why we have 2 verifiable credentials is so that you can still prove that the data is coming from an approved source. And on the verifier side, you have more or less the same. So what I just told you, he shares his public credential and he shares his range proof so that the verifier can verify that it's a cryptographic answer to the question if the income is in a certain range. Well, the demo, I will just show you some slides I made. 5 minutes. I made a few hours ago. So on the left side, you see the website or the system from a social housing corporation. And the customer is logged in, and he is appointed to this certain social housing unit. And on the right side, the identity app. Well, in the identity app, the user had already installed it and used it before. So his personal information retrieved from Rabobank is already in there, well, in a verifiable credential way. So when he scrolls down, he sees, well, the Rabobank, gave him 11 data points. And when he clicks on that, he can see the data points. On the left side, when he goes to the appointment of the, that he's appointed to the social housing unit, and he wants to accept it, so he clicks on accept. He gets like a notification that for this house, he cannot earn more than 42,000 a year. And he can prove that using the My ID app in this case. So when he clicks on the My ID app, well, in this case he will select that he already has the identity app on his phone. Clicks on next, and then he's asked if he already has his income in his phone. Well, in this case that's not already in there, so he will retrieve it from the tax authorities. So when he clicks on retrieve income, and a new tab opens the website from the tax authority. DigiD is used to authenticate by the Dutch government. So he logs in, his income is there, and he can scan the QR code, which is an endpoint, and then the DEDs are communicated to the government. He scans the QR code, and you can see the sign, it succeeded. So in the identity app, the data is there from the government. When he clicks on that, there's actually the income in there. On the website, he can click next again and choose to do the income test in the identity wallet and share the answer of the income test to the social housing corporation. So he does that by scanning the QR code. The identity app is calculating the income test, so if indeed his income is in the right range. When it's succeeded, you can share, like give consent to share his data. And the data is shared with the social housing corporation, and he's accepted for the unit. So that's basically it. Thanks.
Yeah. So how does the system deal with identity proofing? How does it prevent me from asking to borrow your credentials and just verifying, and then
That you retrieve your credentials with your phone?
Yes. As in I borrow your phone and verify as you.
Because in the data that's in the verifiable credentials, there's also your personal information is in there. So when you were logged into the Social Housing Corporation website, they can match them. Does it answer your question? Okay, the first time you start the identity app, you have to retrieve some basic kind of first identity.
Yeah.
So in this case, that happened using the Rabobank system.
So how is sharing prevented? Sharing between like friends or family members?
Like sharing the verifiable credential?
Yeah.
That's saved on your phone?
Or just the phone. Like I take your phone literally from you and use it on the website for me.
Mm-hmm. Yeah, but then the matching component will find out that there's a different name attached to the verifiable credentials.
I see. So your name is bound to, okay, got it.
Where's the zero knowledge? Sorry, where's the zero knowledge proof used? Are you using zero knowledge proofs at all in the or where are you using the ZKP thing?
In the identity app, it's like the proof is generated in the identity app.
So I'm confused. So if you're saying two things. One of them is we're doing this in zero knowledge, and then the other one is like you're fully identified. So why are you using zero knowledge proofs if you're fully identified?
We only use the zero knowledge proof for the income part, and not for the other type of credentials.
Okay, so in one scenario you are fully identified, in the other scenario you're just using a zero knowledge proof. So if you're right, so in this case where you're just using the zero knowledge proof, what's to prevent the attack that Dimitri pointed out? Like I'm just going to share it and use it, because that's the one that lets you get the house, right?
Mm-hmm.
And that was a $1 million.
And that's a great
house.
question for later. Thank you.
That's good. Yeah.
Sure.
Yeah, that sounds like a really good question for discussion. All right, thank you, David. All right, who was it who went sightseeing during the time somebody, okay, Stephen, so where'd you go?
I went to Charles Bridge.
Charles Bridge, yeah, I've heard of that. So what'd you see other than a bridge?
Lots of people.
Lots of people, that's about right. Anything interesting, surprising?
No,
Fascinating?
I'm flabbergasted by the buildings, and I went to Prague last evening, so in the light and the dark it's completely different, and well, as I said, I'm flabbergasted.
That's definitely true. I've been there at all different times of day, and it looks completely and totally different, whether you have the sun coming up behind the castle or on the other side or whatever. It's really, really amazing how it changes through the day. All right. Please welcome Arthur Brock, who's here to tell us something cool about holochains.
Cool. So I did not trust the demo gods to actually run multiple holochain nodes to show you this. So one of my guys actually pre-recorded a demo. We're going to see if the sound works, and we're going to get his narration or whether you're going to hear me. Should at least be able to play a demo, play a video, right? No.
The sound, is the sound plugged in?
Yeah, sound is plugged in.
My mouse is moving. Here we go. There it is.
Okay.
Just have to narrate.
Yeah, it looks like going to be me narrating.
You can also hold
Okay.
the microphone to the speaker and pull out.
I don't know that it. We'll try that.
Sound.
No, the sound is going over the HDMI. So you're going to hear me narrate then. So in the realm of the DID, the DID type management and personal information and verifiable credentials on Holochain, each of those things are completely separate Holochain apps. So they're not built into Holochain, they're apps that are built on Holochain. Deep Key is our key management. You can see key management stuff here with replacing keys and deleting keys, and you can issue new keys there as well. The personal information app is the personas and profiles app, and the The verifiable credentials is designed but not built yet, and it's part of how you can do KYC, have KYC services and stuff underneath Holochain. So we're not demoing the verifiable credentials, and the guy who recorded this is the person who built the Personas and Profiles app, so he mostly focuses on that. If you end up having questions about the key management stuff, talk to Joel in the back of the room. Can you wave just so that if you have questions about that and want to see a demo of that, talk to him, because this is going to mostly focus not on key management, but on personal information management. So those are the multiple different apps that are running. What he's doing now is going into your personal persona. So you could like have a work persona, personal persona, default persona, that kind of thing, showing some of the information that's been entered there. And we have two totally different instances of Holochain running, by the way. Holochain you run locally on localhost. You see how that address is localhost and that address is localhost? So we have a instance running on the cell phone, an instance running over here, and we're entering data via the cell phone right now into a work persona. We're creating a new work persona. One of the things about Holochain is it's agent-centric. And what we mean by that is actually the phone is a completely different agent from the laptop. Now, they're controlled by the same human, but from a computing perspective, since we don't do global state, we do local state, each is a separate agent. So we've entered stuff into a work persona here. He just showed that it showed up over there. Now he's looking at the default persona and seeing what username is showing up there. He's going to change, I think, to the work persona now to show the difference. Anyway, persona, you get the idea of personas, right? You might represent yourself in different ways to the world. So he's going to change to the work persona, and notice the handle changes from @filter to philip.beetle. He's going to enter some data into the default persona for this example hap. We call our dApps, Holochain apps, haps. Makes better puns, like happenings and all that kind of stuff. And he's showing you like things auto-complete if you've already entered some of this data before to give you suggestions. And he's entering these things into the default persona on this side, and then he's going to show you over on the phone that everything has replicated between his two agents that are under his control. So a couple things about the personas stuff is this is not published to a public space. The persona data is personal data and stored on your private chain. It is shared between instances of your agents. So that's part of what he's showing here is he entered the default persona data over there, showing up over here. These things are being shared between agents that are under your control, but it's not being shared to the network. The way you share it to the network is via profiles. Let me just pause for a moment. He started an app, a different app, a peer chat app, kind of like a Slack app, channeled chat app in the left-hand side here. And it's the first time he's running that app, so he hasn't set up a user account in it. So what it automatically does is say, it checks for your profile data, it's not there, so it automatically is basically saying you have to set up your profile. You have to set up a username and avatar and your full name in the profile. But what happens is none of that data is actually being stored in the app. What it's getting actually added to your Personas and Profiles app. And so you can see he's showing that a new profile, we just had the example app before, and now we have the peer chat app as well. And we've just created a peer chat profile. Now he's in the peer chat app, which made him set up a profile before it would run. And he's going to also run that app over here on the phone, and he's going to actually talk in a channel. He's going to be the only one in that channel talking to himself, but it's going to be 2 instances of himself posting in a chat channel. You can see we've got, this is localhost 3003, that's 3001, because we're talking 2 different instances of Holochain here. And he's going to say hello from my laptop and hello from my phone. You're going to see the chat happening with itself, basically. creating a web of trust channel in which to have this conversation. That's kind of the bulk of this. I kind of went really really quickly, and this doesn't work the way blockchain works. There is no the blockchain out there, or like the holochain out there. Every application is a separate peer-to-peer encrypted network. So when I say DeepKey is a separate application from the personas and profiles application and that kind of stuff, it means it's a different address space with potentially different nodes participating. So the data doesn't cross over. So I'm gonna pause and actually just take questions. There's a whole lot probably missing about understanding holochain.
Let's start back here. Yep.
Frederick?
Just for neophyte, because I'm not a very technical person, so we're basically considering this is a holochain is an OS and everything else is an app store. Can you consider it like that?
No, holochain's not an operating system.
Okay.
It's more like a data integrity framework. You could think of it like a distributed database that you can build apps on, but it's a little bit like, if you think of the old days when you would access a database through stored procedures, and that was part of what ensured the data integrity. You can't access holochain data directly, like with some sort of SQL query language or something like that. You do it by making function calls to the HAP, and the HAP is enforcing business logic and rules and permissions and that type of stuff in order to go through and do sense making on the data, and in order to access the data. Does that help?
Yes.
Okay, cool.
How do you resolve state conflicts inside like an ecosystem? So like conflicts to local state synchronizing?
I think you're opening a can of worms question that I don't want to go into too much depth, but I'm going to just briefly say I have yet to see a problem that you can solve on blockchain with global state that you can't solve on holochain. You just have to represent the problem differently. In the real physical world, there is no global state. State is always local, and information propagates about that state. So we have come up with all kinds of real-world solutions for solving this. If you want to take votes for an election, how do you know whether all the votes have been collected? Well, the votes have to be cast at a polling station or a ballot box or an approved method, right? And then you know how many of those need to be collected. And until you've collected the votes from every ballot box, you haven't collected all the votes, right? Because holochain is an eventually consistent data DHT, right? So you have a DHT by which you can query everything, but it's eventually consistent. You actually have to model your problem a little bit differently so that you're actually making sure if you're making a decision on data that's globally, that you have to globally search for on the DHT, globally retrieve on the DHT, you have to model your problem in a way that you can actually make sure you collected all the data required.
Yeah, but globality is like one large audience, right? So if you constrain the audience further and have a smaller subset, you've still got multiple actors that can mutate state and have different
Can we
views of state.
table this because this isn't about the identity stuff. This is a holochain state conversation. Let's table that.
Yeah, I wanted to ask, you had a pseudo hierarchy that may have been false, not accurate to what actually is happening, but you had DeepKey, and then you had personas, and then you had profiles.
Correct.
I have a similar type of thing, except each of my personas has a different set of keys. Whereas, so you cannot connect personas through keys. So I was wondering, different sets of keys for each of the personas and profiles?
And in 10 seconds.
You can create as many keys as you want for different apps that could be even using the same personas, or you can create as many different keys as you want. If you want there to be no way to connect the dots at all between them, they actually need to be running in different holochain instances that aren't associatable through other tracking means. But
all right, thank you very much, Arthur. Okay, I'm going to take this actually. So up next we have the team of Karsten and Juan, who are going to be showing us a Spherity demo. Please be careful, Karsten, there's lots of cables. We don't want you to lose your other foot, like, etc. Here we go.
Yep.
I would like to give a demo about an alternative key management approach. So I think we are all aware of hardware, secure elements, devices, hardware wallets, cold storage, software wallets. And there's a very nice technology that was developed, I think, 30 years ago called multi-party computation. Adjacent technology is homomorphic encryption, and both of them are getting massive momentum in terms of big performance boost for very specific applications. And today I would like to introduce multi-party computation key management for identity solutions. And we are working together with Professor Yehuda Lindell from Tel Aviv and his Unbound team, so with a cryptographer, so basically developing the cryptographic MPC circuits and optimize the circuits to bring them really down to enable key management. And today we show how it's kind of working with an identity use case. So at Spherity, we look in terms of bridging the spheres, physical spheres, objects, machines, biological spheres, humans, enterprises, and digital sphere with digital identity, that across all these spheres, things can seamlessly interact among each other. And key management is, of course, of utmost importance, especially at the intersection of human identity, human owns, controls, gets access to IoT machines, to agents, and whatever it is. And key management software has a problem, even with Shamir secret sharing. I can shred the key in Shamir, I can encrypt it, I can distribute it, but as soon as I recover it, the key is existing in its entirety. And that's where the vulnerability happens, because if the key exists in its entirety, hackers can sneak in, copy the private key, and then we have a clear identity theft. With secure elements and HSM modules, the key is just existing in a confined hardware environment, not leaving the environment. I send a message into the hardware secure element and get a signed message back. Very nice. What MPC key management is doing is basically combining both worlds. A software solution where the key is shredded and never existing in its entirety, in combination with, let's say, the method of hardware. I have to send this message to be signed into hardware, and then I get a signed message back. That's exactly what happens in multi-party computation, but only in software. So how does it work? So the more parties you have encrypted communication among all these parties, the more intense is the computing times. For three-party computation, the problem is being solved, brought down to milliseconds to sign a message with multi-party computation. And that's basically because people have understood how to break down multi-party computation and encrypted circuits and optimize the MPC algorithm for one specific problem, for example. And the problem could be elliptic curve, can be Schnorr signature, whatever it is. But then you have an MPC solution only optimized for this cryptographic primitive, and then doing the signing of a message, for example. In addition, you can also, and that's what's available, to bring the threshold signatures into the MPC circuits or a similar thing, and then you can have quorum policies, 2 out of 5, in accordance to corporate compliance requirements. That's what also can be achieved. And in this little demo, I only want to show you how this works in reality. So how long does it really take to set up a wallet? How do I set up a wallet? Now I need to hope that my 5K player is working. Yeah. So basically, I have now 2 MPC nodes running on Amazon Web Services in the cloud. I have the third MPC device, basically the code on my iPhone. This means when the private key is now being created, when I create a wallet, I have 3 shreds of it, 2 in the Amazon cloud, 1 of my iPhone, fully controlled by myself, and that's what you can, as a metaphor, think about a self-sovereign cloud wallet. So basically, fully controlled on my iPhone, and even, we have to remember, even if we send a message into the little MPC network of 3 parties, there's some encrypted communication and computation going among the nodes, and I get the signed message back, without the need that the key is put together in its entirety. It doesn't exist in its entirety. And that's why it's a safe software solution. You cannot just copy the key when someone signs something and do an identity theft. And yeah, basically, let's give it a try. I have I have here a couple of environments. Now I put here RWOT ID. I can do kind of, let's say, HD wallet for like setting up multiple personas, or just in this case do simple identity wallet. I select devices, so on the cloud I can kind of, let's say, select from devices. With them I control my identity. I have a custom pod environment, and now I start the multi-party computation, creating a vault. And so what's now going on, and that's the most compute-intensive process, to create the vault, to shred it, and to distribute it. And now we have a couple of steps. First of all, now the vault is being created, and I have, so this is my device, MPC encryption is running on my device. Now I have to confirm that I would like to join the vault, and everything I do, so we basically combined with biometrics. Yeah? So when I sign a message, when I join a vault, I also have to do it with biometrics to avoid any, let's say, temporary identity theft because my iPhone is sitting somewhere else. So what have we now done? So we have created a this was a little bit too fast. I created a multi-party a wallet with key-match multi-party computation. And now the next step is what I would like to demonstrate how fast multi-party computation is. I sign an access token. First of all, I'm now sitting in front of my computer. I have to authenticate myself. How do I do this? With my identity. The computer doesn't know that I am I. However, now the computer is generating an access token, and I have to sign the access token. So with my little MPC wallet, with one part of the multi-party computation thread here. So I approve it. It's kind of Face ID, get access to the private key, multi-party computation going on to sign a message, and now I have generated an access token. The second step we do, because first we set up the vault, we create an access token, and secondly we mine a DIT document. That's basically the second step now. I have to approve to sign the creation blockchain transaction to create a DIT document, again with Face ID to get access to my private key. And now the document is being mined on in this case, a private Ethereum blockchain. It's quickly mined. Now I have the DIT document here, and that's what we see here. That's the DIT document with the DITs. We can do some aliases, but I think it's a very nice technology, multi-party computation. If you think about that kind of, not dependent on hardware, access to hardware, or hardware is physically destroyed, you can just deploy the technology. In the future, you will be able to Dockerize it. You kind of combine it with an identity wallet, and you fully out of the box deploy a cloud-based identity wallet with secure software key management. And absolutely, yeah. And that's the strength of the technology, and adding additional security to standard software when I just have private key, expose it when I sign it, and that's where the identity theft that might be vulnerable to identity theft. Questions?
So there's a variety of homomorphic approaches. You mentioned Schnorr. That's kind of what we're working on downstairs in our group. But is it verifiable in the sense that you can verify that you can prove to a non-party of the shares that the shares actually exist and are properly shredded and stuff?
Yeah, so first of all, you have a mathematical proof that the multi-party computation is working in accordance to what you want to achieve. You can believe the mathematical proof. Of course, then it's implemented in algorithms. It's interesting, maybe worth to say that, of course, if you screw up the implementation of MPC, then you need kind of formal verification methods to make sure that the MPC is doing what's supposed to be done. But what's interesting, it's a bit agnostic from the cryptographic primitives. You have, let's say, some very high-level requirements, but when you optimize your circuits for elliptic curve or snort signatures, you can optimize and develop your MPC circuits, deploy them, and then you can run MPC on top of it, and it's a bit agnostic from the cryptographic primitives. You can exchange them. Is it verifiable or not? Yeah, I think there's a mathematical proof. You might want to kind of, by the way, so what has been done with this implementation, it's TÜV certified, FIPS certified, you have to somehow trust the validators, validating the solution would be my answer to this question.
What is the code written in?
Thank you very much.
Yep.
Yep. Let's thank Karsten. Oh, these codes are always so exciting. So next up, we have Marcus Sabadella with the ever-popular DID Resolver. This is our last demo also.
The last one, so everybody will be happy when it's over. And I'm not really going to show something that's very new. Many of you will know this. I just thought I'd do a demo of some of the low-level DID tools that this community has produced for creating and resolving DIDs. And I wanted to start with the DID client tool by Digital Bazaar. So that's a command line tool. It's very simple. I can just type DID and generate, in this case, a VARIOS1 DID, which will be created locally with this tool, and then registered on the VARIOS1 ledger. So here it is. I just created this DID here. I can use the same tool to also resolve it, right? It's just a command line tool for also retrieving the DID document from the ledger. And I can also use the universal resolver, of course, to resolve that same DID that I just created, and I will get back a DID document with hopefully the same keys and services. I can do something similar with the Hyperledger in the client interface, which is can be used for registering sovereign DIDs, or in general indie DIDs. In this case, there's also a command line tool. What I would do is I would connect to one of the sovereign networks, or one of the indie networks. In this case, I will connect to Sovereign's staging network. Then I need to open a wallet. Then I can create a new DID locally. So I type DID new. This will create a new DID with a key locally. Now, since India has a permissioned concept with so-called transaction endorsers, I first need to use an already existing DID which has these transaction endorsement permissions in order to then issue a command to write the new DID to the ledger. So this new DID that I just created with the DID new command, I can write that to the ledger with this command line interface. I wait a little bit, and here's the DID that was just written. I can also again use the universal resolver for resolving that same DID on one of the sovereign networks, and again it will return the DID document of the DID that I just created. And the third one I wanted to show a little bit is BTCR. So I'm not going to create a BTCR DID because that will take too long, but there are actually quite an impressive number of existing BTCR tools that can be used for creating and resolving BTCR DIDs. There's the playground that Kim is working on. There's also a command line tool and JavaScript library by Ori Steele to work with BTCR DIDs. There's even a GUI, so there's a standalone application which is a classic Bitcoin wallet, but also has functionality for creating and resolving DIDs. And I can resolve one of these DIDs, BTCR DIDs that exist already. I can resolve them with the universal resolver. And it has a number of keys, actually. I can resolve that same DID also with the BTCR playground. In this case, it's a slightly older version of the BTCR playground, and I hopefully get not always the same document. There's a little bit of incompatibility, or things are changing, of course. But the point I wanted to make is there are a lot of tools out there, also for YOLOCOM has a fantastic library, which I think is one of the best documented tools that exist in this community for creating DIDs and working with DIDs and credentials. There's a UPort resolver, there's a JavaScript DID resolver in diff that is extensible, supports multiple methods. So basically I wanted to say, I hear a lot here at the conference, we don't have interoperability, right? Everybody's doing their own thing, and I wanted to disagree with that just a little bit, right? So we have all these tools, they work with valid DIDs, with valid DID documents. We have much work to do still, but at least we have a little bit of technical interoperability on that lower level, and this is an achievement that goes to the credit of all of us. At the same time, Mark Miller today warned us that we have 30 or plus DID methods, and there are too many, and building a software stack that supports all of them may be really challenging and complex, and he warned us of that of a crisis in this community, and this crisis also goes to the credit of all of us. Thank you.
Any questions for Marcus? Surely Christopher has oh, good. All right.
Did you use the universal resolver to resolve the did on your T-shirt from yesterday?
It's not so supported yet, but if Mark Zuckerberg wanted to do a PR, I will review it.
What do you feel is the next step for the DID resolver stuff? Like, what do you feel is like the next big piece of work that needs to be done there to take the community, I guess, to whatever the next stage is?
Well, for resolution, there are a lot of open topics. I would say the two big ones are maybe on one hand architecture, right? So I showed a number of different things. I showed a command line tool, which I can run completely locally. I also showed a universal resolver, which is a remote web service, right? You cannot really trust that because I'm running it, so don't trust it. And we need to think about that a little bit, and also for the methods, right? There's a difference between running a full node in my own basement or relying on some remote Explorer API. So this kind of architecture of resolution components. And the second big question is maybe DID URL. So I didn't talk about this at all, but if a DID is a little bit like a domain name, maybe then a DID URL is a little bit like an HTTP URL with parameters, path, query, fragment, and there are lots of discussions and slightly different ideas on how those get dereferenced. And so just working out the specifics of what happens there.
Hi. So you said something interesting just a moment ago, which is, I'm running it, so obviously don't trust it. When, if ever, should we trust a DID resolver?
Well, I would say you can the best setup would be if you run your own full node of whatever of all of them. That would be challenging to run full nodes of all the possible DID methods on a mobile device. I don't know. So you could there are some possible approaches that are being discussed also on the DID resolution GitHub repo. You could, of course, obviously it could be run by some institution or organization you trust. Maybe the EFF runs this, and you decide for yourself you trust that instance. Another idea that has been discussed is you could query multiple resolvers and see if the responses match. So I don't think there's one great answer, but a combination of things.
Any other questions for Marcus? All right, thank you, Marcus. And let's thank all of our presenters one more time. That was great. And I also think we should thank Snorre and Edward, who both had to do a lot more work than they bargained for this evening. They were kept pretty busy.